Hello all. We are going to discuss today the concept of on-track versus off-track lesion. So, an on-track lesion is a non-engaging lesion, and off-track lesion is engaging lesion. Here, see, if you can see, there's a Hill-Sachs defect which is getting engaged onto the anterior-inferior bony glenoid with movement. So, this is an engaging lesion or an off-track lesion. If the lesion is an on-track lesion that doesn't get engaged. So why it is on-track and why it is off-track? Because if the lesion stays within the glenoid tract, then it is an on-track lesion that usually doesn't get engaged. And if it is beyond, it extends beyond the glenoid tract, then every chance of lesion getting engaged with the shoulder abduction external rotation. So the shoulder dislocates very easily if it is an engaging lesion. So based on whether the lesion is engaging or non-engaging, in a non-engaging lesion, usually soft tissue Bankart repair alone is enough and bony augmentation is not usually recommended. But in off-track lesions, there is higher chance of recurrence, so bony augmentation procedures needs to be done. So based on the lesion, whether the lesion is on track or off track, the treatment modality will change. So for that, how can we know whether a lesion is an on track or an off track lesion? If the Hill-Sachs interval is less than or equals to the glenoid tract, then it is an on track lesion. And if the Hill-Sachs interval is more than bony glenoid tract, then it's an off track lesion. So let us see what is glenoid tract and what is Hill-Sachs index. So Hill-Sachs interval, it is the width. If you can see, this is the width of the Hill-Sachs lesion. If we add the bony bridge, which is there between the Hill-Sachs defect and the rotatory cuff insertion, then we get this entire length is the Hill-Sachs interval. And other thing is the glenoid tract. So glenoid tract is the zone of contact of the glenoid and humeral head during abduction and external rotation. So how do I get this value of 0.83 is like in studies have shown that 90-degree abduction and maximum external rotation, the glenoid tract width is usually 83% of the intact glenoid diameter. So if you see, there is an intact glenoid diameter. So how do I get a glenoid tract? See here, it is a best fit circle of the bony glenoid. And if I take the entire diameter, it will be like 2 times B. So I multiply 2 times B is multiplied by 0.83, which is a constant which we got. So then we get some value. That value we need to subtract the bone loss. Say, suppose the 2 mm is a bone loss, we need to subtract that 2 mm from this value. Then we will get our glenoid tract. So once we get the glenoid tract and we have the Hill-Sachs interval, we can say whether the lesion is a on-track or an off-track lesion. So this is the concept of on-track versus off-track lesion. Then how, in the Hill-Sachs, in a bony, in a Bankart lesion, what exactly other things I have to look at is glenoid bone loss. How do I calculate glenoid bone loss? We have to take a best fit circle, take the center point of it, take a radius of it. So this B is a radius. Then 2 times B is my diameter. So I get my diameter, I put it down, and then what is the bone loss which has happened here? That is the diameter of the bony glenoid posteriorly, bony glenoid whichever is left, that is A. So we have to subtract A from B. We get the loss of bone. This part will get it, and that is divided by the total diameter. That is multiplied by 100. Then we get the percentage bone loss. So in a Hill-Sachs lesion, what are all the things we need to mention? Depth of the lesion, width of the lesion, length of the lesion, location, and Hill-Sachs interval. Hill-Sachs interval, what we have seen previously. So based on that, we can see whether the lesion is an on-track or an off-track lesion. We have learned till now. So in this case, we can see there is loss of anterior inferior glenoid labrum with some amount of bone loss which has happened. is a bony Bankart, and we have a Hill-Sachs lesion here. So this is a Hill-Sachs lesion. So let us see the length of the width of the Hill-Sachs defect. This is the width of Hill-Sachs defect. So Hill-Sachs defect is approximately 9.9 mm. Okay. So, and the bony bridge which is connecting between the defect and the rotatory cuff insertion is around 8.6. So my Hill-Sachs interval is 9.9 plus 8.6. So what is that? 5, 18, 18.5. So 18.5 is my Hill-Sachs interval. So this is the Hill-Sachs interval. If we add this both, we get the Hill-Sachs interval. Then we have to see for the glenoid tract. How much is the glenoid tract? So let us see. This is a sagittal image. Okay. And I am putting a best fit circle here. So I'm drawing a best fit circle. I'm trying to fit it. Yeah. Actually, in this case, there is no significant loss of the bony glenoid. So it is almost like a negligible amount of bony loss happened. So if I'm taking the diameter of this circle, then I'm getting something around glenoid tract measuring 2.8 centimeters or 28 mm. So then you can say here whether my Hill-Sachs defect is smaller than bony glenoid tract or it is more. So my glenoid tract is 28 mm. Okay, is it right? No. So how do I get my glenoid tract? I have to multiply it by 0.83. So if I multiply by 0.83, then it is 23.24. So 23.24 is the glenoid tract length. And still, we can see that Hill-Sachs defect is smaller than the glenoid tract, suggesting an on-tract lesion. So if the Hill-Sachs defect is larger than the glenoid tract, then it is an off-tract lesion. So here, so we have measured it. So this is an on-tract Hill-Sachs defect. So less chance of recurrence and only soft tissue repair is enough in this case. Here we see there is significant amount of bone loss in the anterior inferior bony glenoid, and we have a Hill-Sachs defect here. So let us redo the measurements. My Hill-Sachs defect width is approximately 9.2 mm. My Hill-Sachs interval is this, measuring approximately 16.9 mm. Okay, Hill-Sachs interval is 16.9 mm. So I have to calculate the glenoid tract in this case. So I'm taking my sagittal image and trying to fit the best possible circle. This is the best fit circle. And if I take the diameter from the center, so I get my D is equals to 12.5 and small d is equals to 7.3. So diameter lost is d minus small d, that is equals to 12.5 minus 7.3, that is equals to 5.2 mm. So percentage of glenoid bone loss is 5.2 divided by 12.5 plus 12.5, that is 25 into 100. So percentage bone loss is around 20.8%. So we are getting the bone loss is significant, 20.8%. So how do I calculate my glenoid tract here? Glenoid tract here we calculate is 2D, that is 25 mm. So 25 is multiplied by 0.83. So we get uh, in, 25 multiplied by 0.83 is 20.75 minus, what is the bone loss here? Bone loss is 5.2 mm. So 20.75 minus 5.2. Sorry, 20.75 minus 5.2. We get 15. So glenoid tract is 15.55 because we are subtracting s with this 5.2. That is equals to, how we got this 20.75? We have the glenoid diameter, say 12.5 into 2, that is 25. I'm multiplying it 0.83, then I will get 20.75. Then I subtract the bone loss here, then it is 15.55. So my Hill-Sachs interval is more than the glenoid tract. So this is an off-track lesion. So off-track or engaging lesion. So there is every chance of recurrence which can happen.